Thanks very much. My name's Andrew Burt. I'm an enterprise architect with Hatch based in Brisbane, Australia. And I'm going to talk a little bit about our digital project delivery journey, what we've been doing as far as transforming our systems architecture and systems approach for our project delivery processes. So I'll just briefly talk about Hatch. We're an employee-owned company with around 10,000 professionals worldwide. We have projects in around 150 countries across the world with 75 billion US dollars in projects under management. We've got around 68 years of experience and we've been around a fair while. As far as coverage, we cover most of the main areas of the world. So we've got major offices in Canada, the US, Australia and Asia, South America, and through the Africa, Europe, and Middle East, with, as we mentioned before, around 10,000 plus employees. Our main business is around the metals, energy, and infrastructure sectors, and we have a number of services that also support those three main sectors around advisory, digital technologies, environment, sustainability, climate change, project delivery that we're going to talk about today, and dynamic earth solutions. So where did this journey start? So I guess from a digital opportunity viewpoint, we were looking at, what was the opportunity in the industrial asset lifecycle, which is predominantly where our market is. We looked at various studies and found there was close to $28 billion worth of potential market size around digital twins. In a study that was done by around 2040. Now, these numbers are probably actually larger these days from when this study was done, but it's a significant market with our clients that are looking to get the most out of their assets and looking at things like digital twins to do that. Some of the potential areas we were looking to unlock in our project delivery processes was really the ability to reduce our engineering hours, produce fewer classical deliverables, so things like drawings, for instance, to lower our procurement costs, to increase wrench time. In other words, to provide more time in the field where people are actually working on constructing and less time finding information. As I mentioned, the digital twin was a huge part of this as well, so the ability to enable digital twins with the technologies that we built and to improve our margins around operations or improve our clients' margins particularly. Our digital transformation, the vision overall was really to redefine our digital experience for Hatch, our clients, and our partners. And there were 6 main areas that we were looking to focus on. One was the ability to connect our projects across boundaries. Our projects these days are very geographically located across the globe. We use a lot of global work sharing to deliver them, and that ability to connect projects is very important in our ability to successfully deliver. We wanted to look at leveraging disruptive technologies to transform our projects. So what were the new and emerging technologies that were out in the industry that could change the way that we traditionally delivered projects? Look at how we can reinvent the way that people interact and share information, as well as allow us to innovate rapidly as the industry was moving with a lot of the trends that are happening. We're looking to displace a lot of rigid methodologies that we have with much more adaptable processes and replace a lot of legacy technologies with much more effective solutions. Our mindset to driving this transformation was really around 3 key areas: processes, data, and systems. The ability to transform, not optimize. We wanted to really relook at our end-to-end processes. We looked to really solve the 80%, not looking to try and solve every single little part of the process, but what were the main wins that we could focus on and really work on leveraging those. Realizing that data is gold. That was a huge part of our platform move to tools like GridGain. Of course, employee involvement matters. Our users, our functional representatives have to be happy with the tool sets that they use to deliver their projects. And in order to do that, we use a number of trusted partners. GridGain's one of those partners, and along with a number of other partners, including Microsoft and Bentley Systems, Hexagon Systems, SAP, and others. But really, we try and focus on a small number of trusted partners to help us deliver the technologies that we do to our business. And really, from the start, thinking about our clients and our vendors. That's always paramount in our thinking from our culture, is think clients first, and really take a one team approach in the way that we deliver these solutions. So our digital journey started in 2018. We had board approval to actually do this transformation project. It actually started in its planning phase probably 2 years earlier to that, but the actual approval was given in 2018. From there, we moved to our first digitalisation project around 2019, all the way through to GA availability. So basically all new projects in Hatch are now using this platform by around 2022. We now have about 20 new systems that have displaced our previous legacy systems, and we're now moving into really next-gen work, things like generative AI, machine learning, data analytics, etc., looking at really how we can leverage now the information and the platform that we've developed and really enrich our work processes. So from a lifecycle point of view, we're really looking to leverage this digital engine to integrate, not only integrate the project delivery, but also then provide a seamless integration to the operations phase of projects. So really looking at, on the project side, building a strong systems foundation, essentially virtualizing project delivery, making sure that we integrate the construction and commissioning phases of a project and have a seamless handover into operations. And then once that information is built and available, looking at leveraging digital twins with augmented systems integration. So looking at operational type systems, autonomous execution, decision automation, and integrated operations to really leverage all that data and provide a much more richer operations environment where that data can actually start to be used in better decision making, reducing variations and uncertainty in our projects and in our operations side of the execution, and ultimately lower operating costs. So what did we deliver? This is a very simplified slide that sort of shows the enterprise platform that we have developed for our projects to execute their work on. We have through the middle a common data environment, which is essentially an enterprise data warehouse comprising a share center component, which is based on SharePoint. We utilize a technology called iTwin Services from Bentley Systems, which is able to store our 3D graphic content from our engineering design teams. We leverage heavily the Azure services and GridGain in that data repository section, and then we enrich it with tools like Neo4j and graph modeling, and then index it with tools like Elasticsearch. And then we have all of our various tools that perform all the different functions across our projects. So this really indicates, I guess, the starting of a project lifecycle from engagement planning up in the top left corner, all the way down to asset management in the bottom right corner, and all the different features and functions that go through delivering a complex major project that we do every day. In terms of our approach, we're really looking for data-centric delivery. So that common data environment, as I mentioned, it has a documents component, a 3D design component, and a data component made up of predominantly SharePoint, iTwin Services, and GridGain running on Microsoft Azure. On the left-hand side, there's many systems that go into the successful delivery of these complex industrial-type projects. We have a myriad of different engineering design systems that are providing intelligent CAD graphics. We utilize as well various other systems that provide additional information into our projects, whether it be operational information, lab information, information coming from vendors, etc. And on the right-hand side, really, we're looking to provide that information in the form of collaborative workflows to really stitch together our project teams across the world in a much more seamless way. Providing access to data and real-time data. And that's a big thing that's different, I guess, in the environment that we've built compared to traditional project delivery, where a lot of information is actually normally stored and published at various milestones or points in a project's life cycle, whereas we're really looking to harness that information in real time. So really an event-driven system that's able to capture change and push those changes through to the project teams, giving them access to up-to-the-minute information. We also use that information for things like virtual reviews, virtual walkthroughs, as well as embedded web design reviews, which is where we actually review, comment, and use the 3D design in a collaborative way with all this information tied together. Very much building up that initial digital twin. When we extend that to the rest of the project lifecycle, we bring in all the other areas of project information management. So we have all our functions in engineering, but now we start to bring in the other facilities from a project, so the construction side, the construction planning, the geospatial aspects with tools like Esri, and then the commissioning and the procurement project controls aspects as well that are required to actually manage these major projects. All of this information needs to be brought together into a seamless database or a seamless common data environment that's able to deliver all that information to our project teams, both in the office and in the field. So that's in the forms of data management, with dashboards and real-time information, KPIs on project success, project timeliness of information, access to that information. And another core feature of our environment is work packaging. Work packaging, which basically creates small, manageable chunks of project work that's defined by scope, budget, and schedule. It defines the parts of a project that will be executed by different teams and allows us to execute those packages of work and control them at a more granular level. That work packaging aspect is key to the successful delivery of our project and is a major part of our common data environment. And then once you've got all this information, you need to be able to find it. So search is another core feature of our platform that we've developed. With all this data, information validation is very important. So making sure that the right information is delivered in the right way, correctly at the right time to all the different project participants. To do that, we use a number of different technologies. We use business rules and various design information validation rules on the GridGain environment and on our Bentley iTwin environment, which is the 3D modeling aspect. We use data quality rules running on Azure functions that are able to actually take data in real time and verify it. And the outputs of those things are data validation, the ability to compare data across systems. As you could imagine, if you're storing data in a myriad of different upstream authoring tools, you need to make sure that that data is consistent. So the information that's inputted by an engineer on day one of the project needs to be consistent with the information that is used in the procurement process, the commissioning and construction processes, and ultimately handed over to our owners for operations. So data comparisons and data connectivity are very important in making sure that the data set that we're assembling is not only rich, but accurate. We also do a lot of dashboarding of information, of course. We've got to provide information to clients, as we mentioned, and also to our project management teams who want to see KPIs on the status of the project. So I mentioned briefly around work packaging. What we've done in the case of work packaging is we've actually coupled our GridGain environment with Neo4j and use Graph to basically extend the power of GridGain from a distributed data point of view to include that graph modeling capability. And it really enables us to leverage the best of both worlds and bring together a really powerful environment where we can now model all the work packages and all the information that's created on a project, whether it be an individual working on a project, or it could be an asset like a pump or a piece of steel that we have to construct. Every single piece of information is gold and needs to be tied to a hierarchy of some form that we can then manage. And the combination of GridGain with its distributed database technology and Neo4j with its graph capabilities gives us a really good engine to actually deliver that to our project teams. As far as our overall architecture, there's a lot of moving parts. We've got something like 30 plus systems that we've ended up either developing or integrating with other off-the-shelf systems, and all of those have to be integrated in some way across the project landscape to support that whole life cycle. As I showed on one of the earlier graphics, we have our common data environment that's used basically as an integration backbone for that entire project delivery process. And underpinning that is a rich REST API layer. We've basically built APIs across all of our various tools, including commercial off-the-shelf tools that we've built APIs on top of, where we've been able to embed things like our security management requirements, dealing with all the cybersecurity aspects of an environment like this running in the cloud. We have multiple different ways of ingesting data from these authoring tools, from bulk data ingestion pipelines, where we pull out bulk data on a regular occurrence through tools like Azure Data Factory, and also event-driven mechanisms where we actually are raising change events and processing those through message bus and service bus type architectures like Confluent Kafka, service bus event grid, and Logstash in the form of Elastic. All of these event mechanisms, as well as the bulk data ingestion method, are generating information that finds its way into our GridGain platform. And to do that, we use a lot of microservices. We've really built out, I think, a fairly rich microservices architecture that goes with this platform. From a data persistence point of view, we're using all sorts of technologies, all of which is pretty much running in Microsoft Azure. So we've got data lake storage for long-term historical data. We use Elastic, as I mentioned, for search. We use SharePoint for collaborative documents in Office 365. The heart of the data platform is GridGain. Why did we choose GridGain? Really, I guess traditionally, a lot of the work that we've done has been around SQL databases, Microsoft SQL or Oracle. But really, one of the things that was really different was that we've tried to build an enterprise platform. So it's a single consolidated platform that's servicing our entire world. As I mentioned, we've got 10,000 people across the world, and we're basically using that single service to deliver all of our projects. And traditionally, that hasn't been possible with non-distributed systems like Azure SQL or Microsoft SQL Server or Oracle. We've either relied on SQL replication or we've deployed systems per project. So every project that we stand up that we have to execute will actually deploy a set of services and systems and databases to go with it to do that. So really we were looking for a major scalable distributed data system, and that's where GridGain came to the surface. I mentioned that we use tools like Neo4j from the graph point of view to further enrich that GridGain experience. It just allows us to really model those deep relationships between the information that we're generating, and it really ties together the digital thread that is the information that we're generating. And then we use, of course, iTwin services and other things like Storage Blob and application insights and things for application monitoring. Various different API layers. We use GraphQL, Azure Functions. We're using Microsoft Fabric, all sorts of REST APIs, OData APIs, etc., to ultimately deliver information through a series of AngularJS user interfaces. We have our integrated search experience. We use Unity for some of our VR and 3D design review capabilities, along with Power BI and Elastic's Kibana dashboarding. So that's really the general architecture that we've put together. From a usage point of view, it's quite a success story for us. So this is over the last 5 years. We've now got in excess of 6,700 engagements or projects that are active across the world. We have generated, you'll see there, 500 million events that have been generated in terms of change events, another 75 or nearly 76 million events just coming from Ignite alone. So we're using heavily the continuous query service on the back of GridGain. 1.4 billion FileBeat events, which has really changes that are going through into our search platform. So there's a significant amount of data. For some systems that I'm sure people in the room are looking at, maybe these aren't big numbers, but for an engineering project type environment, these are pretty big numbers from an enterprise point of view for a system that's only been running for around 5 years. We've developed, we've archived 41 million documents from previous systems. We've generated nearly 4 million collaborative workflows in this environment. But this is just a bit of a snapshot of the sorts of usage that this platform is going through, and a significant component of this is our GridGain data platform, which is housing all of our live data. So with that, I'd like to hand over to Greg Capil, our lead developer, who's going to take you through more details on our actual GridGain journey over the last few years. So thanks, Greg, over to you.
Thank you, Andrew. Hi, my name is Greg Capil. I am a software engineer and the lead technical developer on our digital project delivery scope of work based out of Mississauga, Canada. Our journey started back in 2021 with Apache Ignite. We started with Apache Ignite because it offered several compelling features that aligned with our initial requirements, some of which included cost-effective entry point, allowing us to explore in-memory computing, the in-memory data grid capabilities, promised high performance and low latency, which were crucial for our data-intensive applications, and the platform ability to scale horizontally by adding more nodes to the cluster was a key factor in our decision, ensuring we can handle increasing data volumes and user loads. During phase one, we successfully deployed Apache Ignite using Azure Kubernetes services to host our initial instance. We also established a centralized location for schema management. Our solution leveraged our in-house developed application called Engagement Configuration, which enables us to deploy schema changes and cache configurations to Ignite. In our phase one implementation, we created caches and tables per project with approximately 400 plus caches per project. We initially allowed each project to have its own schema. This setup worked for our initial needs. However, as we progressed, we encountered challenges. Complexity in configuration. We struggled with understanding and configuring key concepts such as affinity key or partitions. In our phase one implementation, we chose to use project across all our caches as our affinity key. This was done because if we didn't have project as affinity key when using tools such as dbeaver, our SQL queries didn't return all the data. With project as affinity key, it ensured all the data for that project was on one node, hence always returning all the data. But this had consequences, as we later learned. Is also, as a result of this, we also, these decisions, we ultimately faced an unstable environment. Oftentimes, one or more of our pods would restart, and we had to restore backups from our drives. As we were dealing with the instabilities in our systems, we recognized the need for robust support and advanced backup capabilities. We made the strategic decision to transition from Apache Ignite to GridGain Ultimate Edition so that we could leverage the network backups, point-in-time recovery, and the full and incremental snapshots to ensure there was no data loss. However, here we also encountered a few problems. Limited feature utilization. We realized that we were not utilizing all the features available to us, which hindered our ability to fully leverage the platform's capabilities. We were still using our in-house backup and recovery strategy, which was very time consuming. Our teams were using incorrect drivers when using dbeaver, and as a result, we were not able to utilize all the features we had purchased. We had purchased Control Center, but it was not configured, and we were not using it to monitor query or cluster performance, which we would have, which if we had, we could have seen issues very quickly. In summary, we adapted a new technology without fully appreciating best practices for working with distributed systems, including Apache Ignite and GridGain. Next slide, please. In late 2023, we recognized the gravity of the situation we were in, and we decided to engage GridGain to conduct a comprehensive technical deep dive into our implementation. In early 2024, GridGain and the Hatch team met in person at the Mississauga Hatch office and conducted a deep technical review. This thorough analysis revealed numerous issues from our Phase 1 implementation, prompting us to undertake a complete redesign. To address these challenges, we engaged GridGain consultants to collaborate closely with our team. Their expertise and insights were invaluable in guiding us through the remediation process. Some of the key highlights from their recommendations included a complete schema redesign. This was essential to streamline our data architecture and improve overall system performance. We moved away from our design of allowing each project to have their own caches to having one global set of caches. At the time, our production instance had 8,000 plus caches with only 21 projects. And now we have 400 caches in total, 30 plus projects and counting new ones every day. A different implementation of the affinity key and partition strategies was for distributed data. This change was crucial for optimizing data distribution and ensuring efficient data access. Our previous choice had led to a very unbalanced cluster, as not all projects are the same size. We have very small projects and very large projects. When we ran SQL queries on very large projects, there was no distribution, so only one node would have very high resource usage, and eventually the pod would recycle due to resource starvations. Improved security. Enhancing our security protocols was a top priority to protect our data and maintain system integrity. We created multiple users with different permissions, optimized .NET and SQL interfaces. These optimizations were necessary to improve the interaction between our applications and the database, resulting in better performance and user experience. We denormalized to limit joins. Some of our queries have had upwards of 15 to 20 joins. We moved the heavy processing of data that was done by the SQL to using services which were written entirely in C Sharp. This is very important to us as we use the .NET stack and we don't really have any Java developers. In one case where we process upwards of 100,000 records at a time, we moved the processing to a service and the time reduced was from 10 minutes to about seconds. So today we run the queries in about a second versus 10 plus minutes. We also implemented Apache Kafka. Integrating Apache Kafka and using the GridGain Kafka sync connector helped us manage real-time data streams more efficiently, providing a robust solution for the data processing. And finally, we reconfigured our GridGain environment in AKS. It was also determined that we had misconfigured and didn't assign proper resources to our nodes. We allowed the processes on the pods to take over all the resources without leaving the operating system any resources to run its process, leading to pod restarts. These strategic and technical changes have significantly enhanced our system's robustness and efficiency. Today, we have a properly balanced cluster. We have experienced no downtime and can confidently keep deploying our projects to the GridGain platform. By learning from our initial challenges and implementing these expert recommendations, we have positioned ourselves for a more resilient and efficient future. Our Hatch team has gained valuable insights from the GridGain experts, and we are now confident in running the platform and managing future changes. Okay. Today in our GridGain ultimate environment, we have compute jobs and services, all written in C Sharp. We have also implemented continuous queries for our data export service and engineering consolidation service, ensuring seamless data flow to downstream systems, improved and streamlined SQL queries. We have deployed our systems in Azure Kubernetes services, which offers scalability and reliability. We have complete CI/CD pipelines. We are leveraging GridGain Ultimate's features in our production environment, including rolling upgrades, production upgrades to minimize downtime and ensure continuous improvement. Additionally, we utilize point-in-time recovery to restore our systems to specific state if any issue arises. Our backup strategy is comprehensive, incorporating both full and incremental snapshots, as well as network backups to ensure that data integrity and availability. Next slide, please. Okay, this is just a quick overview of what we have implemented today in our data ingestion and processing philosophy. So from the left, we have raw data sources. Today, we collect data from multiple sources, including engineering design tools, scheduling, material management, and procurement. These are just a few. It seems like every day there's a request to add yet another source of data. These sources contain valuable engineering project and operational data essential for decision making. Then we move on to raw data and ingestion, completeness checks. Data enters our data factories, functions, web jobs, APIs, where it undergoes completeness checks. This step ensures that we are working with full and accurate data sets, helping prevent gaps in our analysis. And as we can see, the JSON's formatting allows for seamless standardization across and interoperability across all of our platform. And then we move on to data consolidation and consistency checks. Most of our data moves into Confluent Kafka and then using the GridGain Kafka sync connector into GridGain Ultimate, where it is aggregated and checked for consistency. Some data comes from blobs, which are bulk loaded using services written in C Sharp, which run inside the cluster and use the thick client. And we also have applications that use the API, which uses the thin client to connect to GridGain cluster to write data. And we move on to application processing analytics. The process data is exported from GridGain using continuous queries and what we call the change capture service to downstream systems such as Elastic and Neo4j, but also to our reporting solution, which is in Fabric. By following this structured approach, we ensure that our data is not just collected, but transformed into a strategic asset. This philosophy enables smarter decisions, streamlined operations, and ultimately a more competitive and data-driven future. Next slide, please. Today, we are in phase 3 of our implementation. We are currently in the process of migrating to GridGain 9 Ultimate to further enhance our system capabilities. We have also successfully transitioned to the Confluent Kafka platform, which will significantly improve our ability to grow and manage the platform. This concludes our presentation. Thank you for your attention. I trust that you found the information both educational and insightful. I would now like to open the floor for any questions you may have. Thank you.